So as I was saying, I intend to be starting gently, and we'll talk a little bit at the beginning of it as to the motives for what we are going to see and our motives to create BigML as it is, as the API-first platform. And you'll see that it comes very handy for machine learning, and that's the real goal that we tried to fulfill. And well, the structure more or less is explaining that, and then seeing a little bit of our tools to do some client-side workflow automations, and some examples of these client tools. And after that, we'll compare these different tools, and we'll see which are the advantages and drawbacks for each one of them. And when when will you prefer to select one or the other, and which conditions are important to do that. So first, as I said, we thought about machine learning, and from our point of view, machine learning is becoming something so widespread and so integrated, or should become something so integrated into your information systems, that when we thought about what we wanted to build, we were very sure that we needed all these goals you see here. First, we needed accessibility because it will be spread in your company. You will need to reach it from everywhere, and today networks are anywhere, so you need to have this kind of accessibility. You need automation because, as you saw previously in the other presentations, you know that machine learning is something highly iterative, so you will need to do processes once and again, and you need to automate that. You won't be happy until you automate whatever you use as your creation pipeline. And also you'll need interoperability because nowadays we have so many gadgets that can execute something. They can do predictions. I have my mobile, you have tablets, you have anything. You'll see gadgets like Amazon Echo doing it in the demo. So you need to be able to provide a way of putting your models, the information of your models inside of all these gadgets. And also you need ease of use because finally humans like to see why things happen, why the models predict what they predict. So you need something to show humans what's being built behind the curtains. So these are the ingredients that we wanted to get, to fulfill. And we did because we thought also that machine learning should become a system service, one more. We've seen during the years, during the decades, how every single thing that we added to the information systems was transformed into a kind of layer that abstracted the difficulties behind that thing. We started by having hardware, just hardwired things, and we went from that to providing a kind of software that helped us manage these things, these hardware things. In the same way, the next step was making this abstraction layer for operating systems. After that became, we had many computers tied together by networks, and we also provided a new abstraction layer to manage these networks. And you don't have to take care about the TCP protocols. Someone does it for you. So you need this kind of abstraction layers, also for databases, for distributed systems, to be able to manage easily every tool you get in every century, in every decade. And now we think that the time has come for machine learning to become that. And we don't only want to build a perfect model with a perfect score. We want that model to be able to be put in production in minutes or seconds. We want that model to be able to be rebuilt from new data that we get. We want that model to be available everywhere to be used in the company. So we need to provide an abstraction layer, right? And what do we need in this abstraction layer? What does the machine learning world need from us to provide in that software? Well, for sure, we'll need to be creating things. You've seen today that we created sources and data sets and models, and tomorrow you'll see another kind of logistic regressions, and tomorrow we'll talk about the unsupervised models, so you'll see there's plenty of them. And you need to be able to update them or to delete them, so you need to manage these resources that you're creating. You also need to be ingesting high volumes of data and transforming it, because you need feature engineering, as we said. So we need to provide some way of putting our data into this kind of layer that will transform it into knowledge. And we also need to produce from that some results, some predictions, some relations between clusters, or some anomalies detected by the anomaly detectors. So something that can be produced either locally in one of these devices that we were talking about, or remotely. If you have a high volume of data, maybe you want a service to do the work for you and just get the results. So both things are needed. Finally, you need an abstraction layer over the algorithms. The algorithms are there, are known. The academy has found them during the years. And what you need is to use them, not to know about the intricacies of how they are computed. And most of all, we will need automation, because we will need to be able to use that into our integrated systems, as I said, and repeatedly reproduce it, have it in a traceable way, so that you can know at every step what has been done and do exactly that if you need to with new data. So these are all the things that we came up, the list of things that we came up of thinking about the needs of what we needed to provide. And what did we do then to provide these needs? Well, our choice was to do, as I said, this kind of REST API interface. And well, I don't know how many of you are familiar with that kind of language, of engineering language. So if someone feels strange about this, that doesn't mean nothing else than you have a kind of syntax that every software engineer will understand. It's like the URLs that you type on your browsers, that you just know how this syntax is used, and you know what information you have to provide to this URL to get something back, and how this information gets back to you. So it's nothing less and nothing more than that. And the operations that you can do with this kind of URLs are the typical operations that you use in HTTP. When you use HTTP, you can post things, you can get things, you can delete things, you can put things. What does it mean then? Well, when you post things, you are really creating things. When I want to create a source, I post my data and get something back. When you get things, of course, is you retrieve the information that you have previously created. When you delete, of course, you delete, and when you put, you just update some of the contents. Maybe in this case, the name of a data set or the name of one field. These operations are naturally mapped to the HTTP because, well, it's the traditional protocol. And what's the way of handling this information that we'll need to give to the API interface and get back from it? Well, you could choose many syntaxes, but we chose JSON because we think that it's a lightweight language that has a structure and gets, you give some attributes and get back some attributes more. And from that you can, this way you can manage the information back and forth. In this case, in BigML, really the rest, it's a bit of tricky because it's REST plus. I mean, whenever you send a create call and say, please create a source for me with that information, you get back a response of the API saying, okay, I heard you, but you might not get the finished resource because sometimes you get a lot of data. So would you wait sitting there till you get all the resource needs created? No, it's better if you get back a response saying, well, I heard you. Maybe your demand was queued or will be started. And after that, it goes in progress. It creates the object that you demanded. And finally, it finishes and gets back the real information that you want. This means that this call goes back and forth and returns something that is not really the final thing, usually. So it's an evolution. You need to call again, asking, well, how's my demand? How's that source that I wanted to create? And every time the API will tell you, well, the status now is, and will say in progress, or finally will say finished. When the thing that you wanted to create is finished, then you can start working with it and having a look at the attributes that it has. Of course, when you do that, well, sometimes you get errors. Because in the process, you can have maybe a field that probably you thought that it was a datetime, but they had some things inside that were not exactly complying to that format or whatever condition it raises. So finally, you have to keep in mind that whatever you ask for might have an error and not end in a finished resource. So you have to check for that whenever you build something in this kind of setting. And now that we know more or less the environment that we're moving on, I'd ask you, to those who still don't have registered in BigML, please, if you want to join me, you just have to go and register by putting any user you want here in this, in this register screen. You can access that here. In the upper menu, you see that there's a sign up and gets you to this kind of form. So you just need to specify your full name, after that the email, and choose a username and a password. Remember to use the promotion code that we did give you earlier, which is MLSEV. And with that, you will be ready to go and start building your first model. I just would like you to join me and do your first model in BigML. So whenever you register, if you have any problem registering, here how it's only the CTO, so he can gently go and help you. Rest your hands, and maybe he can give you a hand, right? But I hope that you won't have any problem. But if you do, just ask for help. So whenever you register, you should find yourself in a kind of list like this. Mine is empty. Yours should contain some sources, so some examples of data that you can use to build any model that you want. But let me walk you through the dashboard also to see that there's, at the bottom, this column which says gallery. And the first item is datasets. If you go to datasets, you'll find out that in BigML, we have quite a lot of datasets available for you to start making your models. And they're classified according to which kind of things they deal with, and you can choose from them. So I have here a dataset, which is called steel plates, if I remember correctly. Here, steel plates faults. This dataset is one of the available in UCI, and we just cleaned it a bit and put it in order, and has been uploaded. So whenever you find a dataset in the gallery, you just can clone it here by pressing in this label here. So if I do this, that dataset will become a dataset of my environment. I will be able to use it to create models, to do whatever I want with it, right? So what's the thing that I challenge you to do today? Well, I'd like you to use this dataset and just clone it into your environment, as I said. We'll see how it's done. From that, we will be able to create the first model in BigML, your first model in BigML. And from that, I'll ask you to predict what's the fault for this kind of conditions. If you have a steel plate which has a type of steel of A300 and log X index of 2.2, the model that we're going to build will tell us which is the expected fault that this steel plate will have. Okay? So we'll try to build that. We'll try to answer the question, if we build a steel plate of this type of steel and with this log X index, which is the kind of fault that we will get at the end. Okay? Try to do that. So the first step, I will guide you through the first step, as I said, was going here to the gallery and getting this dataset for free. And what happens is that you clone the dataset into your own environment. Okay? So when you do that, you see, as I said, that this data set has many fields. Of course, this is just measurements of the different quantities that someone thinks that might influence the kind of faults that you get in one steel plate. And finally, the important thing is that at the end of it, you have, mind that I just asked me to show 100 fields. Maybe the default is 10, so you might have to paginate a bit, but otherwise you change the limit and you will be able to see it all. And at the end, as I said, there's this field which is called fault that stores the kind of faults that steel plates have. And it turns out that there's, in this example, the training data has 402 instances where they had bumps and much more or less where they just were dirty and sometimes had some kind of scratches, so case catch, and other faults, which is a general category. The thing is that there's different types of faults that can be expected from different steel plates. And we don't know which are the reasons to have one fault or the other. And when we have a steel plate, a concrete steel plate, and we are able to provide all these measures that you see on top of it, we'll be able to predict which is the fault that is expected for it, what's going to happen with this steel plate. But for that, we need to create a model, right? Is what Paul did this morning several times. So maybe you're already familiar with it. Do you see this action here? That's the action icon. And it shows you all the different supervised and unsupervised models that you can choose to use with this data set. Okay? So what would you say that you need to do? Do you need to use a supervised or an unsupervised model to predict which is the kind of fault that I'll have in my next steel plate that I get? Supervised, okay. So you were not sleeping, that's right. And then what we need to do is choose one of them. We will choose as, we could choose, if we wanted only to predict, I want to predict that, we could choose from any of the available models that you have here. But if you, on top of that, want to know the reasons for one particular steel plate to have a concrete fault, then you better choose the first one because it's the decision tree that will tell you not only the prediction, but also the fields, the things that are related to that prediction, the features that are really being important telling you this prediction. So let's do it because it's quicker, all right? And then what I would do is, now that you, hopefully, some of you at least, have built that model, can you answer this question? Doing something? What would we do once we have a model built in BigML to answer that question? What would you create? Sorry? Evaluate? Well, if you wanted to know if the model is good or bad, of course, that's the practice that you should follow. First, you should evaluate. And if you see that the evaluation is good enough, then you believe the model. But in order to predict, I mean, even if your prediction is wrong, in order to predict, you only need to provide your input, right? And create a prediction from it. There's nothing else to do. There's not much work to do. So the next step that we should do is creating a new object, a prediction. So the prediction should be created also from the actions menu. You follow us? And then we see that we can either predict question by question, where the model will ask us for the things that really matter to tell apart what happens. But as we have all the values, I choose to go to the predict form. And I see that I already have here a default prediction, right? The way of presenting the predict form is telling you, well, I've put the mean in every field that I have. And for that concrete steel plate, the prediction is that the fault that it will have is that it will have bumps. and that this prediction has a confidence of 60%, okay? But that's not the question I'm asking. I mean, that default prediction that I have has a series of features, of concrete features. So the log X index is 1.83, the type of steel is it's not A300, and I want to know exactly what's the prediction for this kind of, okay? So you can use the form to get that prediction right. Just mind that here there's these all input fields. Sorry, I don't know why it starts. Let me rechange. There's this all input fields checkbox that should help you just remove the rest of information of the rest of fields. Cannot. Oh. Yeah, again. Sorry. Okay. It's, no. Oh, you can see it. Okay, that's fine. Okay. So now that I don't have any input fields selected, that means you see that the prediction has changed. This is a prediction for the case where you don't have an idea, you don't have a clue as to the properties of the steel plate that you're producing. When you produce a steel plate and you don't have a clue at the properties that it has, the predictions is that most of it, of course, will have all the faults because it's the majority, right? You saw that the category that was the majority of times is all the faults. So we want to know the prediction, but for the one I said, that is log X index 2.2 and type of steel A300. Anyone, I've not done it, right? I just checked the two fields to be used, and I just need to fill in the values, 2.2 in log X index and type of steel 300 set to true. So anyone can tell me the prediction? Sorry? Case catch. Okay, and which probability, which confidence? Let's see. Fine. So I have an advanced student, I'm happy. So that's the first model and the first prediction you did in BigML. That's as easy as it gets. I mean, you have your data, you build your model, you fill in the data that you know about the next case that you want to predict, and you get a prediction, okay? That's the thing that you do as a human. Now, do that for 1,000 steel plates. Or do that after 3 months where the model has changed. How do you do that? Like this, one by one, with someone introducing the exact measures of every steel plate in a form? Of course not. I mean, you need automation. That's what's important. So let me tell you how you did that without knowing. BigML, as I said, is a REST API first platform. So whenever you clicked and created something, you really were sending things like this. You were just calling a URL, which is called HTTPS, BigML.io. This auth stands for an authentication set of variables, right? You just were telling, it's my environment, I'm authenticating. And here, for instance, I'm just creating, in the first line, I was just creating a data set, because the endpoint was data set, from an existing source. The source, or each object in BigML, is identified with one ID. You can have the ID, which is here in the URL, as reference to do whatever you want with that object that is created. You can use it. It's immutable, this object. So whenever you change your data, you don't have to be afraid of whether you are changing that object. No, it will never change unless you create another one. So that brings traceability, which is very important if you need to audit the procedures that you do, and you need to repeat them. And what you did in the first line was creating, as I said, a data set from a source, which had this ID you see. In the second line, you created a model from a data set which is the thing that you did with the interface. And in the last line, you created a prediction using some input data. And that's what you did with the prediction form. So even if the platform gives you this kind of application that is showing to you these forms and these models, behind the scenes, these are the calls that are running. And every time you do a post, as I said, there's an evolution, and you have to keep getting the object until it is finished, and it gives back the real prediction. So that's the first thing. You have automation. You have automation via REST. But of course, on top of that, you will want also to have ownership of your resources. When you create a model, you don't want that model to be part of the platform and never see it anymore. At the beginning, Google Prediction API did that, and you only could do predictions, but you were not able to retrieve your model, or you didn't know what they were doing with it. So we think that it's really needed to have this ownership because the data is yours and the models are yours. And also because you might need to use them in places which are outside of the platform. For instance, as I said, we can see how you can use that in Alexa, in Amazon Echo. You just build a model. Sorry, because the sound is not playing. Perdona, el sonido no me está... Paro. A ver si ese volumen, sí. Seguramente estará quitado, no. No está quitado el volumen. Bueno. Well, that demo, it's...
What is the patient's body?
Now?
The latest diabetes model is loaded. BigML is ready.
Make a prediction.
You can make playback, Paul. You can do the playback.
180.
What is the patient's body mass index?
35.
What is the patient's diabetes category?
1.
The prediction for diabetes is true, with a confidence of 91%.
Okay. What happened just right now? Well, Paul was interacting with this machine, Amazon Echo, and Amazon Echo was asking Paul about the different tests for a patient, which came to ask whether he was diabetic or not. So he asked for the plasma glucose, he asked for the BMI, and finally, when the model ended up giving a real prediction, it produced the prediction. You need to integrate your models with things like this. So you need to have your models locally to be able to do whatever you want with them, right? And that's our main goal here. So as I said, there's this REST API, and you need to download these models. These models that you have in BigML, of course, are downloadable. And in fact, are this JSON. Let me show you, just for the sake of it, one of them, the one that you built. This amount of JSON with some properties and values is what you see in your screens as a tree just splitting. Contains all the information. It's just a way of putting it, a syntax that encloses the information in your model. And this same document that encloses that, sorry, because it gets again, this model that includes that can be downloaded to your machines, and you can use it from there. That's what we're going to see. But in order to do that, in order first to be able to automate things more efficiently than doing each HTTP calls and just having this information in JSON, you need some help, right? I mean, we all like programming languages because it allows us to do things more efficiently and more quickly. So we developed some bindings to many programming languages, and you now have you can now use for instance, the Python and the Node.js bindings that will help you to do that. And well, as I said, what we just built is this kind of workflow, right? We just created a data set in this case, but if you had your data, you first should have uploaded it into a source, produce a data set, a model from it. You just brought some input data and created a prediction for that input data, for that concrete input data. That's what you did. And that's a very simple workflow. But in machine learning, as you know, there are very complex workflows. So we'll need to do better than what we did before with a dashboard in order to automate it. And that's what we do with our client tools, right? So first, to start using client tools, well, let me tell you, well, how many of you, when I say Python, think about a snake? Okay, so very few. So even you can follow us if you want. But for the rest of us, I just recommend you, I have a Jupyter notebook that I can share with you. It's in GitHub, and you can clone it. And for those who have no Jupyter notebook, you have no Python, have no GitHub, you can still follow because you'll see that there's a service. I'm not sure about the reliability of it, but you can try. So for the ones that really don't think about Python as a snake, and for the sake of it, how many of you think of Monty Python instead of Python? Okay, so we'll meet afterwards, right? So we will first create, if you want, a virtual environment to keep your work isolated. It's perfectly possible to install BigML bindings in your computer without virtual environments. If you want to do so, just do it. But the only thing that you need to install to be using the bindings and all the client tools is just software called BigMLer. So if you do pip install BigMLer, you'll be downloading all the things that you need to run every automation in your local computer, right, in Python. So the first thing that you need to do after installing is checking that you really can access the API, right? And to do that, you need to identify yourself. You need to provide environment variables. In my case, my user is Mercè_demo, and there's an API key. So the next question is, where is the API key? Where do I have my API key? Okay. My API key is always available in the dashboard so that you can use it and clone it. Here it is. When you go to the dashboard, in the top menu, here, sorry, you can see this kind of sign between parentheses, which shows you your API key, right? Here you can see the variables that you need to put in your environment to be able to access your models, and data sets or whatever resource you built. Then after this session, I'll have to just use a light to blind you, and then you won't remember anything else. So no, it's easier than that. We have also a place where we can change the API key here. Here. You can see that there's a place where you can recreate the API key, and there's no problem, okay? So you will remember what we did today. And after that, well, if you set your credentials and clone the repo, as I said, the repo is available there in GitHub under my user, which is mmercè/notebooks. And there's a folder which is called MLSEV that you can use to follow the presentation. For those who don't have these tools in your computer, there's a service, a website, which is called mybinder.org that allows you to execute Jupyter notebooks. I'm afraid it's a bit crowded these days, so maybe you have to be patient, but in case you want to try, that's the other option. So once we are set with that, or you should be set with that, we can go to the notebook. And that's the aspect that it should have, is this workshop notebook. And we'll try to go step by step to describe what you should do if you want to use BigML from your computer by automating it, integrate it into any Python application. So first, of course, you set your credentials, as I said. And after that, you'll see that the API calls that you issue are containing these credentials, right? They should have this syntax. There's the domain, the general domain, which is BigML.io. Here, I'm going to try to list the sources that I have under my environment. I put my username, I put also my API key, and that's the kind of URLs that I would use to see the list of sources that I have in my environment. And if I execute that with a curl to see what happens, it should show me one of the sources. And that's, of course, as I said, a JSON document that has an object stack which contains the list of sources that it's brought back to me when I ask for that. Okay? That's what I would do if I was doing just HTTP. But we want to use instead the Python bindings to be able to use it easily. So in the bindings, there's an object which is called BigML, which contains all this information that we just mentioned that was in the URL. So to what domain are you connecting to? Which is your username? Which is your API? This kind of information that you will need to repeat every time you call the API, it's stored there. So you don't have to worry about it, putting it every time. And what you do with this class is instantiate it. As you see, I didn't put here my credentials because by default, the class is able to retrieve it from the environment variables. So if I set my information, my credentials in the environment variables, the class just retrieves it and it's fine. And finally, if I just execute and show the attribute URL, I see that it correctly extracted my information from my environment and created this URL that I was mentioning that is going to be called every time. The URL that connects us with the service, with the platform. So if I want to list the sources, just as I did before with the HTTP call, the only thing that I have to do is use this API object, this connection object, and ask for the method that does it, which is called, strangely, of course, list_sources, which is very, very simple. Okay? And I'm putting here a parameter which is telling, well, just give me one of them, because otherwise the list will be very big, and I would like to show it to you. So, oops, I think I just jumped a bit. Okay, so that's the list of the first source. The last source that I created is here. The information about the last file I uploaded and source that was created is just here. And it's in a JSON, which in Python is naturally mapped into a dictionary for those who use it. Well, then let's think further. Let's do a workflow, right? This prediction workflow that we did click by click, how is it done here? Well, first let me show you that I have a file in my computer, which is called diabetes CSV. So I have a CSV, nothing else, which contains data about patients that might or might not have diabetes. Okay? And let me show it to you. We can show it here. You see that the fields that it has is the number of pregnancies, the plasma glucose, the blood pressure, the skin thickness, insulin, the level of insulin, the BMI, and finally, a field which is the one that is telling you this patient had diabetes or no, he didn't. So the diabetes field, which will contain true or false. And the first thing that I need to do, as I said, is load it, right, in the platform, because that's in my computer. That's not there. So let me be tidy first, and I create a project, so a kind of environment just to put the things in, and to be able to manage them in group. When I create a project, I just set a name. As you see, I create a project by using the method create_project of the API object, so it's something simple. You list sources, you create projects, is verb and object that you're using, nothing else than that. And this project that has been created has also some information inside, right? And what does a project have? Well, the number of resources that it contains, nothing else. A project is nothing but a container. That's nothing else. Either name, and the name that I put that is set to MLSEF Python bindings example. Okay, that's the kind of information that I have. But what are the main levels of this object that I get back always? You will always have a code which will tell you whether the HTTP response was successful or not. You will always have an error field, which is hopefully empty. The location, which tells you where to find this resource that you just created, this project that I just created in the platform. And the API response is inside of a tag, which is called object. I mean, the real response of BigML is included in that tag. And how do I know what's the reference that I need to put to identify this project? Well, there's this resource ID. The resource ID is the unique identifier that I told you that I could see in the URL previously in the dashboard for every object. That's under an attribute of this thing that I just got back, which is the attribute resource. So if I just retrieve the attribute resource of this thing that I just created, it will show me the ID of the project that I just created. And I just put it there in the project variable. And sorry? Yeah, I did, but the thing is that I put it in a project variable. I didn't print it, okay? So the next thing that I'm going to do in that workflow, remember that workflow that we were trying to follow? So the first thing that I do is uploading my data and doing a source. So I do that. I just create a source. You see, API, which is the connection, create a source. It's the method. The first argument is the file that you want to provide. The second argument, any other attribute that you want to set attached to that thing that you're going to create. For instance, a name. For instance, if you want to put tags. For instance, in which project will it be created? So whatever you want to attach, this meta information that you want to attach to the source that will be created, that's what I put in the second argument dictionary. And when I do that, I just get something back, okay? And the thing that I get back is, well, yeah, I'm creating it, so the code is all right, it's 201, but it's mostly empty. I mean, I don't see here, for instance, the fields types. It should contain something, right? I'm putting data there. It should give me back an answer telling me, well, I found so many numeric fields and so many categorical fields or whatever. And it doesn't. Why? Because as I said before, the API answered before finishing the task. And then you can see here, what's the status in the moment that the API answered to me. And the status is the source creation request has been queued and will be processed soon. So I need to ask back and wait until the source is really created to have the information inside of it, to have the real content of the source. How do you do that? Well, of course, not just doing calls get. There's an utility which is called API OK, that when you pass the information about the source, will wait for you and do as many calls as needed to get back the finished thing with all the information. So once you run that and see the result, hopefully you will have something much more informative, right? Here you have the field times, for instance, and you see that there's a categorical field, there's a total of 9 fields, so it has finished analyzing the data that you've just uploaded. Let's see if it's true, if it has uploaded something in the platform or just pulling, I'm just pulling your leg. That was the old project where I was working, and if I change to the project I just created, well, here a source appears, right? That's the source I just created from the IPython notebook. And as you see, it has the expected fields and all the information and everything is fine. That's the first step. I did the first step. Okay. So I go to the second, and the second step should be creating a data set, right? I mean, once you have uploaded your information, the next thing that you need to do is just creating a data set from it that will just show the distribution of the values in each of the fields that you have in your original file. And you do that by calling create dataset, the create dataset method of the connection. Again, the same thing, but creating another thing. And the argument that you have as input is, of course, the source that you want to start from. I mean, you can tell which is the information that you want to as origin for the data set that you created. And again, another data set was created. And the next thing that you do is just creating your model. So create model from the data set, and here something else appears, which is important, the objective field. When you want to predict something and you are doing supervised learning, there's one field which is somehow more important than the others, because it's the one that contains the prediction, the real value of the field, of the thing that you want to predict for the historical cases. And that's the objective field, the thing that you want to predict in your case. So you need to tell the model which is the field that you want to predict, because in this case, I want to predict diabetes, but I could want to predict whatever BMI or the age or whatever. It's in the data set. I could choose any field in the data set to do that. So I use it in the second argument. I give the objective field. And after that, you just create a prediction by providing some input data, right? You have some input data. Before in the dashboard, we used the dimensions of the steel plate, you remember that, and the type of the steel plate. And now, as we are talking about diabetes, we'll provide the results of tests for the patients, for instance, the plasma glucose and the BMI. And when we provide that and use the model we just built, by calling the create prediction method, you will be able to produce this kind of prediction. So this is the same thing that we did in the dashboard. Now you have a workflow here, a complete workflow that is able to do it for you. And you can see it there. That's the complete workflow that do that for you. But as I said, this is the same that we did in the platform. And the platform, when I did it in the platform, the prediction was not done in my computer, right? It was done in BigML. I asked BigML, tell me what's the prediction for this steel plate, and it brought back a prediction. Can we do that locally? I told you that we want to do that locally, right? Because I want to be able to do that in the Alexa machine, in your mobile, whatever, in places where there's no connection to the internet, and I want to be able to do that. So the bindings also provide this kind of utilities to do that, and the way of doing it is, for instance, asking for to export the model that you just created and put the information into a file, a JSON file. And whenever you have this in a file, you just can use another class in the bindings, which is the model class, that receives this file as input and is able to use it to predict locally. I could delete the model in BigML, just remove it, it doesn't exist anymore, and then you can still use it locally in your computers, right? Let's see if I can do that. And that's my model JSON. And I just, as you say, it's just a moment, and you got the same prediction that I created before remotely. So both options are perfectly okay, and you can do whatever you need to do. Of course, this is a very, very basic workflow. And what happens is that what if you have to evaluate? Well, if you have to evaluate, you have to follow another workflow, right? I mean, you have to do things like this, create a data set, split it into a train and test halves, using the train data set to create a model, another test data set to evaluate it. So that's becoming a bit more complex. But what if you have to do what Azure says that it's the churn workflow, which is simpler, of course, in BigML, but whatever they say, if you need to do a workflow like that, which is similar to many workflows that you can find in the real projects that you maybe get into. Well, of course, doing it by step, maybe it's tiresome, right? Can we do better? Can we do something that can help us do the workflows without having to code step by step, saying, now you have to create the source, now you have to create the data set, now you have to create the model? Well, it turns out that we can, otherwise I would not be saying this. And we have first a tool which is called Vigor Miller, which is a command line tool that where you just need to give it's a declarative tool. You just need to give the information that really makes the change. I mean, you know that the prediction workflow is a standard workflow. You always follow the same steps. And the evaluation workflow is the standard workflow. You will always follow the same steps. So the only thing that will change is which is the file that I will use for training, which is the file that I will use for testing, which is the parameter that I will use in that model. There are some things that will change, but only those. The steps that you take are the same all over. So you can just provide these things that change into options, right? You just write Vigor Miller and provide some options. Train from my diabetes file, which is the first thing that we see here, test with another file, which is the diabetes test file, and put everything that you create in an output directory so that I can later take a look at it, put it in a project, tag it, and put some name on it. That's the thing that it's variable, but the workflow is more or less standard. So you don't need to code. You don't need to use Python. You don't need to have coding skills. You just put that and put a batch command and repeat it every time you want, or just program a cron to do that for you. The same can be done, of course, when you do this, a lot of opportunities just open up for you because the canonical workflows, all of them can be just coded like this. I mean, you can use the evaluation workflow, which is just a variation of that with an evaluate option at the end that knows how to do the splitting. You tell it, well, I want to split in 20-80%. Okay, so it does. And finally, it evaluates and creates evaluations for you. So that's a good way of just avoiding the complexity of going step by step in any of the workflows. And of course, you can do things more complicated than that. You can even retrain with cumulative data. So if you just train the model with a small sample, and then you want to repeat exactly the same, you have here a command which will be able to retrain for you. Just say BigML retrain at and the name of the file that contains the additional data, it uploads it, and according to you just give the ID of the model that you used originally, and it deduces from that the steps that it has to take to reach a new model with the new data accumulated to the one it had before. So you can do things, but of course you cannot do everything because these are canonical workflows. You can even code more complex things, but not everything. So as a summary, what did the thing that the REST-Polish ML interface that I described do? Well, it was an excellent abstraction because it was transparent to the data model. It has immutable resources, so it's traceable. It's simple and yet effective, and has an easy access from any language that you want to have bindings for. And all the algorithm complexity and computing resources are hidden behind this layer of abstraction. So that's a good start. But of course, the way that you have to use this scripting is difficult, right? I mean, it's not so usable. So there's not a simple way of handling errors. It's not discoverable. It's not so scalable because its complexity keeps growing if you have to take care of every single call. And after that, we see another kind of layer, which is the bindings that I just mentioned. So you don't take care about these kind of interactions, waiting for things to finish. There's a lot of details that you can still need to take care about when you are drawing this workflow step by step. There's no interlanguage compatibility. The client-side workflows that you want to do are not so easy to be optimized. And the reproducibility is also a bit noisy. So even if we have bindings, maybe we would like more abstraction than that. And then we can think about the declarative solution that I just mentioned. So that abstracts this complexity behind a kind of layer. And thanks to that, you can do things like cross-validation. I don't know if you're familiar, but mainly it's that you do several evaluations with different parts of the data and finally average all of them to have a better grasp of what the performance will be. But this complex thing of handling these parts and doing these averages can be just compacted into one sentence, okay? But finally, even if you do so, there's always this going back and forth from my local file, from my local computer to the platform. There's problems with scalability. There's only a subset of the possible infinite workflows that you could draw that can be done like this. So what do? Well, you call your CTO, and maybe next day he will be explaining how to overcome that.
Yes, just a teaser for tomorrow. Yes, come tomorrow, same time.
Yeah, tomorrow same time.
And you won't have her, you will have me, so that's not so good.
He's
but
funnier.
We will be talking about how to bring all this client-side automation to the server. So this is cool, and this works, and this is the usual way in which you do automation in many platforms. You write your client-side stuff, and you try to simplify as much as you can, and you, for instance, use declarative tools like this one, like this BigML, but this has limitations. Mercè already has told you about them. There are even more, and essentially, everything was simple when you were creating single models. Just one line or two of Python, and you get a model finished after you wait a bit. Or you do an OptiML, and you get hundreds of models built for you, and you get the best one, just one click, just 2 lines of Python. But then you start doing things like this complicated, or not so complicated, but start to be complicated workflows, and things get complex on the client side again. Suddenly you have to take care of errors. What if one of these steps fails? Do I retrade? How do I parallelize? What if I want to do this 100 times or 200 times? How do I do that in parallel on my client side? Those are problems that come back to you. We had solved them for one thing. We have workflows. We have the same problems again. So tomorrow we are going to talk how we solve that. And the way of solving that, well, is called WisML. It's a domain-specific language. It lives in the server, and what we are going to do is bring in all this complexity back to the server and make us happy again at the client side. So tomorrow the idea is to explain a bit how this WisML idea works, how we create workflows instead of on the client side, on the server side, and we'll write we'll do a little exercise writing workflows on the server side.
And remember that even for those of you who are not skillful programmers, there's the way of doing that automatically without you having to code.
One of the nice things is that you have a magic button that you can click and create a workflow, even if you are not a programmer. Even if Python is a snake. So, and we'll have some fun with that.
So if you join us tomorrow and you had not enough from us, we'll be happy to tell you about it. Thank you.
And if you have any questions?
Yeah, bye.